Okay, good afternoon, everyone. I am going to be talking about using Landsat technology to identify mangrove restoration needs. This is part of a bigger project, but this is the most delicious aspect of it. I'm the main person handling the GIS and Landsat technology, but I've had a great team of mangrove experts behind me to help interpret the information and develop the restoration needs plan. In Southwest Florida, we have a good appreciation for the importance of mangroves to our habitat diversities, as well as the importance of mangroves to adjacent habitats. And for a long time, we've been concerned about the decline of mangrove forests. And we've been concerned about that for a pretty long time at the CHNEP. Early on into the implementation of our CCMP, we had funded Terry Tatter to look at the dynamics of tree mortality and mangrove recruitment within black mangrove die-offs in Southwest Florida. So we have been concerned about it for quite a while. Now, we've used Landsat data to look at this issue. It's available free at this website, and it includes a portion where you can look at the quality of the images that have been acquired, how much cloud cover there is and so forth. In the CHNEP, we have two scenes that make up our study area, Path 16 and Row 41 and Path 16 and Row 42. And what that means is these images are taken during the same swath of the satellite passing our study area. We can also use Path 1741, which completes the upper left-hand view, basically the Tampa Bay area, but it's in a different time period than the ones that are taken in the CHNEP area. This information downloads as a TAR file that can be uncompressed and then reveal georeferenced TIFF files, so you can bring them right up into ArcGIS or whatever GIS viewer you're using. Landsat mission, the first Landsat mission was launched in 1972, and in fact I believe it's in our CCMP that we have a land use map from 1972, and it's no coincidence that those two dates are identical, that Landsat technology had been used by USGS and others to interpret all sorts of information on the landscape. Landsat, there are different band ranges, and it varied by mission. So from one Landsat mission to the next, it's not identical, so you have to be concerned about that. And then also Landsat 1 to 7 data are by percent reflectance, and then Landsat 8, which was launched in 2013, is by a digital number that can be converted to reflectance or radiance. It's a much bigger number than the percent reflectance, so it's more detailed and more sensitive. Landsat 5 in this medium green is the longest running mission, and then Landsat 8 is the most recent mission. And in fact, Landsat 7 has some problems with georeferencing, so I like 5 and I like 8. So if you want to use Landsat, use 5 and 8, I endorse them. The information comes down in bands. In Landsat 8, there are 11 different bands. The first band is for coastal and aerosol studies, and that's new for Landsat 8. These numbers range, in this case, from 590 to, it runs from basically 0 to tens of thousands in this range. And when the numbers are unpacked, they're just numbers. And what I'm doing is showing these numbers as an expression of this rainbow view. So these are just numbers, but I'm showing them to you in color. The second band is blue. There's a blue band for all the Landsat missions. There's a green band, again, for all Landsat missions. There's a red band, band 4 for all Landsat missions. Then it gets really good. Near infrared. Woo! This is a band that you won't find in normal aerial photography, and so this gets really exciting. And that was also for all Landsat missions. And you can see how clean the water is, that the shoreline is really delineated really cleanly. The mine reservoirs are really showing, and then also in open wetlands where you have the water reflectance, you can see that too. So this band is really good for assessing. I wish I had this knowledge for our reservoir work that we did, and you can look at how water is held on the land with this band. Another exciting band is the shortwave infrared number 1, and it discriminates moisture content of soil and does other neat stuff. And then shortwave infrared 2. So those are both in older Landsat missions. Then there's panchromatic. It's a more detailed one, but it doesn't do anything other than make things look pretty. There's a band 9, which is also new for Landsat 8, and that helps you interpret cloud cover. And you can see, because we're not really seeing anything in this one, that this date that we acquired on January 28, 2015 was a very clear date, and we had superb imagery from that date. Other days when they have a lot of cloud cover, it's not as easy to interpret through the clouds, and that's what this band is for. You have band 10, which is a thermal band, and then you have another thermal band, and this one is new for Landsat. And they're doing a lot of climate change assessments and thermal assessments using these bands. And you can see how hot the urbanized areas are, and that's one use of this band. But now the really good stuff happens is when you combine the bands together. So this is a band that looks at natural color. Red is red, green is green, and blue is blue. So this is what the satellite is seeing, basically. But when you move that set up one, you get a false infrared. And so you're showing blue is green, you're showing green is blue, red is green, and near infrared is red as you composite this. And when you bring them up 2 levels, this is what you get. So you're starting to play these different bands like chords on a piano to have different interpretation of what you're seeing, and you get different information out of it. This is when you move the top 2 up a 3rd step and leave one up 1 step or 2 steps, and you get a false color infrared, a false color image that we used on our 7-county watershed report. We had an earlier version of this particular color choices on Landsat. And then you can change it again, and then this is channels that were recommended by a researcher in Indonesia, and he liked how this particular set of compositing shows mangroves as orange. And so we did that. So again, you can play these different channels like a piano. So those are the Landsat missions. Okay, this is all the different vegetative indexes that were tested against mangroves in the Yucatan, Mexico. And these researchers found that green normalized difference vegetative index had the closest match to the canopy chlorophyll of mangroves in the Yucatan. They found that this index, looking at Landsat imagery, explained more than 80% of what they were measuring on the ground. And so out of all these different vegetative indexes, NDVI green, which uses near infrared or band 5, and green band or band 3, and using this equation, replicates what they're seeing on the ground in mangrove canopy chlorophyll. So the more photosynthesis the mangrove forest was exhibiting and being measured, the more the near-infrared and the green bands were finding it through this equation. And so as I progress, I might be using the term canopy chlorophyll, NDVI green, or mangrove condition, and they're all synonymous with this equation. So there's a broad, long range of Landsat missions that started in 1972. The Landsat 5, which I endorse, started in 1984. And so we pulled some Landsat 8 imagery from January 2015 and compared it to January 9th, 1985. And even though the data are exhibited differently, we can compare them. And in fact, the bell curve in NDVI green is pretty close. And in fact, at this point, I had abandoned using the 1999 data from Landsat 7. There were georeferencing problems. the bell curves didn't fit as well. And so I really liked this comparison, and that's what I went with. So this is what it looks like. This is canopy chlorophyll and the mangroves throughout our study area. So the bright green is high levels of chlorophyll, and the reddish that you see here is low levels of mangrove canopy chlorophyll. Now, we use that information with my team of mangrove experts and identified 90 potential restoration projects. We identified 121 areas that had decline due to natural causes. Most of these were sea level rise into basins and just can't make any modifications or restoration to stop that. And a lot of them were Charlie. We were still seeing effects of Charlie using this method. From our shoreline study, we thought that most of that had been cleaned up, but it's more on the shoreline side, and we're still seeing some mangrove condition issues from Charlie's passing. And then we also found 113 sites where we say, yeah, there's a anthropogenic problem here, but we ain't going to fix that thing. And then 3 where the mangroves had a problem. There was a restoration that was already being implemented. And so we'd like to see how that that changes in the long term. What I'm going to do, as much time as I have left, is I'm going to show you some really interesting examples. I would love to show you all 90 restoration project potentials and some, all 119 cases of it being natural causes, but I don't have the time. But I put in a number of different images I thought would be explanatory of what we were seeing. In one case, or in several cases, we went into an area that it said that it was declining, the mangroves were in poor condition. We were at 1,000 scale or something, which is actually pretty close, and saying, boy, that mangrove forest looks fine. What is this data talking about? And then we go in, and oh yeah, there are these broken branches. You can see the branches. You can see the condition difference. And just that change of scale from 1,000 to 500, we saw what the data were saying. And for a team of mangrove experts to go through without that detail flagging areas of potential condition problem would take a very, very long time. So we found this tool as a great shortcut to look at places where mangrove condition were questionable and identify potential restoration options. An example is, this is Cattle Dock Point. Let me help you with the interpretation. The green here is high NDVI, or good mangrove condition, we think. The oranges in here are where they're poor, and we use this magenta to show areas of change. In scrub mangroves, you'd expect the chlorophyll levels to be less, but if it's less and we've seen it drop since 1985, there's something going on there. So we were able to use this change to discount areas that we think might just be naturally low, and then look at them a second time, and oftentimes we said, oh yeah, there's a problem here. In this case, it's Cattle Dock Point Road, and this road was put in years ago, even before the waterway was dug, so it's not really doing much that I know of. But it's not been culverted, so it's stopping flow across here. And if you go to an aerial photograph, you can see this road here. You can see obviously that the hydrologic changes between each side of the road is different, and it could probably use a culvert, and we recommend a culvert right here. But for these salt marshes, some additional culverting would probably help those salt marshes too. This is an area we call the Big Die-Off. It's a big black mangrove basin. We've been seeing changes. It's pretty obvious, and it's pretty obvious in the data too. We've seen changes since 1985, but we're also seeing areas of condition changes, or poor condition here and in here, and this will help you identify areas that may not be obviously dying, but might be an area that you have a concern for the condition. And in this case, you have the spreader waterway behind it. That's the hydrologic problem of this area, and there's just no remedy, and that's why we've tagged it for no remedy, but we know there's a problem. And that's what the big die-off looks like. And in fact, you have batis or saltwort that can come in underneath the dying mangroves. And it often provides a substrate for either young blacks or reds to come in. And when we see these changes in mangrove forests, we think that's a good thing and a natural thing in the course of sea level rise. This is another area. This is County Road 771 here. This is what I call Little India. I think they call it Placida Point. If you look up the tidal creeks, this is all Catfish Creek. It's in good condition, green, high levels of canopy chlorophyll. But when you go up this tidal creek, it's not such a good condition. So we were able to go out and we identified that there are culverts, but the culverts are allowing the water to flow from the west side of 771 into a pond, I guess it's an old borrow pit. And so it's depriving the creek from water flows. So as 771 at some point in the future, if they're expanding it, that would be a good time to move the culvert. And so we've recommended that. There are also areas of mosquito control ditching and spoiled berms, and that's what's causing the condition problem here on Ponce de Leon Point off of Punta Gorda. Those mangroves, even though there are mosquito control ditches, they're in pretty good condition. And so we see this as a tool to evaluate areas where we have mosquito controlled ditches. And, if it's in poor condition, we can consider it for restoration. But if the mangroves are in pretty good condition because of the way the mosquito control ditches carry water and not disrupting flow as much as other mosquito control ditches, you can leave that alone. So that's a use for that tool to identify areas where you think there might be a concern, but then discounting that as a concern. And you can see some things from space, like mangrove trimming. In this case, we saw a single red, a change. This had changed since 1985, a lower condition, and it's gotten worse. And when we looked at it, it was in a large area of trimming. And so you can even see trimming from space. In some cases, we saw the little magenta squares that indicated change, and underneath was a dock that had been built since 1984. And so there's less mangroves and therefore less canopy chlorophyll in that pixel. This is off of Little Pine Island here. You can see Matlacha Pass. And what we did is we did site visits in some of these areas. This is a site that we visited right here. And you can see this is where we had walked to. Actually, we walked this way to get out of here, and we walked that way to get out of it. And as we were walking through here, we saw that the tidal creek was very soft and indicative of mangrove that was declining because its roots are rotting and the sediment is getting opened up into the water, and so it's very soft and it's degrading and you can smell it, and that's what we smelled in here in this orange area. And so this is a view of what that looked like. And in fact, we saw witch's brooms, which is a sign of mangrove stress, and in some cases, red mangrove scrub, which I didn't know existed until I went out and saw it myself. And so this is mangrove stress, and so this is an area that could be considered for some hydrologic improvements. And in fact, let's see, there's a old canal here that could be ditch blocked and help with the flows. And then the Pine Island Road, evaluate it for culverts, because you can see it degrading along here in this area, and it might be that a culvert right here would help with the flows between these two areas and improve mangrove condition. This is Pine Island, and this is the mangroves, and this is Pine Island Sound off here, so it's the western side of Pine Island, and some big areas of mangrove die-off. And there's a berm road here, and we recommend a culvert here. And this is what it looked like in 1953, and this is a big area of black mangrove basin. And probably with sea level rise, and it's possible also that this area had been cleared when the wetland lines were, at mean high water, and it was cleared, and they were farming it, and then as sea level rise inundated it, made it no longer useful, then it was abandoned, and then it just opened up as now an algal marsh. This is off of Bunch Beach. This is Summerlin Road out to Sanibel. This is Jim Morse Road. And this is a large area of mangrove die-off. And we recommended some culverts to help with the flows around here. And this is what it looked like in 1953. This is Big Hickory Island. And it's kind of interesting. This magenta shows change. And so this road was here in 1985. Ooh, I better get hurrying. This road was in here in 1985, but through trimming and clearing to make the road wider open, you can detect it. And then also we had recommended a culvert here because back in 1953, these waterways were more open. And then this is an example of how we propose implementing the plan. This is Ponce de Leon Park off of Punta Gorda. We see some areas of lower mangrove condition off this area. There was an old tidal creek here. There are no culverts along this road, and they're currently doing a plan update for the park, and we recommend culverts in these locations. And as the park is renovated, it's at that point in the capital improvements that you can add these features to improve mangrove condition. This is an example of the changing mangrove condition. These are areas where they are lower condition than 1985. You can still see the effects of Charlie along the edges, but there are some areas on the interior where you have had some flows where they have been improving. And along the creek, they have been degrading, and that's why we recommend the culvert here at the road. That's the location of the tidal creek. So we have basically three uses of Landsat and the NDVI green, restoration planning, which you've seen. But I'm also excited about using them for environmental indicators. That in 2002, when we were developing our environmental indicators, we could get a target for mangrove extent, but we had a hard time identifying a target for mangrove quality. And so using this tool to look at mangrove condition is a great measurable way to assess mangrove quality. And also in restoration monitoring, you look at structural changes, how the habitats have changed, but you also want to measure a functional change, and we've had a hard time with that, and we've been looking at fish communities. But looking at mangrove condition after restoration would be a great way to monitor restoration and see its effectiveness. We've had some additional findings, but that's the project team, and that's just a taste of what we're doing, and I'm very excited about NDVI as a tool. Okay. Ooh, I get to answer questions while Moran changes the slides. Any questions? How frequently are the satellite passes made? Every 19 days. Yeah. Yeah, every couple weeks or so, every 19 days. And it's been doing that since Landsat 5. And so you have a lot of great choices on imagery to find the dates with the best imagery. In 1999, it was December 24th, we had a really good pass, and that's what I had used for 1999. I imagine you could, these are 30-meter pixels. And so you might be able to detect some change, but with a pixel of that size, I don't think you'd be able to see the tidal changes very easily.